My name is Doug Cook. I'm Associate Administrator for Exploration Systems Mission Directorate. The Ares 1X project was initiated really early in the ESMD. Once we got into about 2005 and really started this program and defined what Ares 1 was going to be. The concept was frozen, actually, for the test. It was conceived really by ATK along with Scott Horowitz, who was the associate administrator at that time, and Mike Griffin, the administrator, and they came up with this concept and set this team in motion. They picked a person to lead it. It was Bob S., who did a tremendous job. He followed the work in relocating from Houston to Langley, then to the Cape, and then back to Houston, and had a strong team that he put together. They were learning every step of the way. This was the first time that this had been done for a launch vehicle since shuttle program, and this time it was done by people who weren't there during shuttle. The shuttle actually was managed early on by the Apollo managers from earlier era. So this was the first launch vehicle by a new generation who pulled together and figured out how to do this, learned from what they could of the past, and pulled this together and did it in record time. In my thinking, they did from beginning to flight. It was about 3 years. So it was a very fast effort, well done every step of the way. As we got into this and got closer to flight, we were talking about it more, of course, and talking about what we were going to learn from it. We had just completed the Augustine Committee, where we were providing them data and that sort of thing, and this flight was coming up. We were asked, what is the relevance of this test? What are we going to learn from it? And we put together a package on all the things that it was going to teach us. And of course, at that time, there was a question as to what we would be doing going forward, what decisions would come out of the Augustine Committee. So, as it turns out, at this point in our history, we have a different way of evaluating or learning the abilities of vehicles of this type, and it consists of a lot more math models. We do wind tunnel tests for aerodynamics. We do a lot of analysis, but we have math models that predict acoustic loads, aerodynamics, and that sort of thing. And so a big part of this test was actually to validate new models that we were just using really for the first time. And so then there was a question as to whether this configuration was actually going to give us very much information, because it was our design of the vehicle, Ares 1 at that time, had evolved. The front end of it was a different mold line than this particular test was. So there was a question, well, this is not even the right configuration. Are you going to get anything from it? But there again, we had it fully instrumented with tremendous number of instruments in order to validate math models. And we had flown this vehicle in the wind tunnel. We'd gotten all kind of wind tunnel data. We had the math models for this configuration, and if we can match all that up, it tells us our models are good. And so it actually tells us for the vehicle with the different mold lines, with what we're actually going to fly later, that the math models give good predictions. So it was worth a lot from that. We're also going to learn a lot from control of this long, slender vehicle. There had been comments along the way on the Ares 1 that we were going to have an issue with the aspect ratio of it, the fact that it was so long and slender in terms of control and bending and that sort of thing, and so we wanted to learn about that. Another important aspect of it. Actually, the control during the first stage and seeing how well we did. Roll control was a concern potentially, and one really important aspect of it was that we had a team that that had gone through this entire process, and we thought it was important for them to see what they did right and what they did wrong. They learned a lot of things along the way just during working through the various center cultures and that sort of thing. But it was important to see the whole thing through, and so that we would know that we had succeeded or we had shortfalls, we had problems that we didn't expect. So it was important to take it through the actual flight to understand what we knew and what we needed to work on. So it was very valuable just from the standpoint of validating what the team was learning and what they would take forward in the future. One thing that had come up in discussions was whether or not we would have an issue in flying shuttle if we had a mishap with Ares 1X, because we're flying, actually it was a 4-segment booster, same as shuttle flies, in a different configuration, a different flight mode, and so if we'd had an issue, we would have had to work very closely with the shuttle program to clear it for a flight. I mean, you would obviously ask those questions. We actually had gone through. We actually did go through some of that sort of thing with one of the development motor tests out at ATK when we were actually firing a 5-segment booster on the ground in a test out there, and we didn't get it started the first attempt, and so the team rapidly went into an evaluation, working closely with the shuttle program. If I remember right, I believe it was DM2, and maybe it was DM1, but at any rate, there was a shuttle flight closely following that firing, and we actually even before the firing, we had talked about whether or not we ought to wait until the shuttle had flown. So at any rate, as soon as there was an issue, there was a lot of pressure on trying to understand exactly what had happened and making sure that we were safe to fly the shuttle. That's something you normally get into if you're flying similar or hardware that's very close to something on an operational vehicle. From my perspective, as we got into Ares 1X, we were getting regular reports on their progress. They were under the gun to get this thing built and flown as early as possible in order to keep the cost down, primarily, and actually get results back that would feed back into the design process. So Bob S. was selected as the project manager. He selected a team. It was really operated separate from the mainline program, just so the mainline program wouldn't be their focus wouldn't be off of what they needed to be doing. So we had this team in place. They were learning to work with each other. It was a multi-center team, which can cause complications because everybody does everything a little bit differently, and they have different standards. They have different approaches to design and that sort of thing. So Bob S. had the challenge of bringing this team together in order to get this done in a short time, but actually integrate them and have them working together. Also bringing in the contractors with the booster. They got avionics from Lockheed Martin for the actual flight computers and that sort of thing. It was from an Atlas, and so it was pulling together a lot of different aspects of this design in order to get this test off, and they did it in about 3 years from start to finish. They had to streamline efforts. They had small teams. They were doing most of the work themselves, and so they had to come up with their own approach, basically, and how to get through this process quickly. I think it was very valuable. They obviously succeeded in doing that. They pulled this off in what I think is record time, and did a really good job of it, and everything was working really well. They had a lot of instrumentation that had to. That was one of the bigger concerns, I think, getting into the real time crunch, getting all the instrumentation up and calibrated and tested to make sure it was all going to work. And there were discussions of, well, how much of the instrumentation do you have to have? What are the critical measurements? If you have these out, do you go? So there were a lot of discussions like that. There was a lot of verification work to get to the end that they had to really work through in pretty much record time. I think they had quite a bit, a day or two before the flight even, that they were working through, and they were knocking it all out, and they got finished and done. So they actually made it work with a streamlined team. They did shed some things that we probably would normally do on a flight. But it was a test flight, so you can afford a certain amount of that. Although it was high profile as well, so you really did want it to work and not have a big failure in the process. So that was a challenge. I mean, it's not like no pressure for it to work. At the same time, you want to streamline it to get it done quickly. And they learned a lot. They had a lot of problems that came up in different standards of like shielding wiring from what was done on the Atlas to what was done on a shuttle vehicle, and there are probably a lot more of those than I even know about. But they worked through them all. It was lesson. It gave us lessons about how to do that in more of the mainstream program. I believe. I think those the things that were learned and the processes that they came up with were valuable in terms of informing us on how we can operate on the more mainstream program more effectively. And so through your process on the knowledge capture and lessons learned, I think that will benefit us down the road as we set up teams, because in the current environment where we're looking forward to the MPCV, Orion, and the SLS, we have to find efficiencies, and in order to be able to successfully develop these vehicles and within the budgets that we get. And so learning from this work that was done on Ares 1X is really very helpful to us in terms of understanding what we can do successfully, where we can streamline without sacrificing success. And so it is instructive. And one of the concerns I guess I had along the way is since we had a totally separate team from the mainstream program, Constellation program, you worried about whether or not that information transfers. And so an important aspect of the work following that is to infuse the mainstream effort with some of these people, with a lot of these people, but also to capture what they have to say about their experiences and what they learned, so that we can actually learn from it and implement that downstream and get the efficiencies that we'll need. My early jobs at NASA were working on shuttle flight testing in aerodynamics and entry. And I worked through the approach and landing tests that were done in '77 and the first flights of the space shuttle. And a lot of this reminds me of that time, because in the work that I was doing, it was something that was kind of added on. I think management realized, well, we're not flying a capsule anymore. We're flying a winged vehicle, and we're going to have to make sure it flies properly and according to what the wind tunnel tests tell us and all that, and the simulators and that sort of thing. So I worked with people across various centers, similar to what was done on Ares 1X. I had a team that consisted of people from Dryden, which was involved in Ares 1X, actually the Air Force at Edwards, people at Langley, people at Rockwell, contractors back then. And we had a very small team of people many of whom had worked on the X-15 and lifting body test out at Edwards, and we came up with the instrumentation that we needed. We had to get that all integrated through the shuttle program, but we had a very small team, and it was a pretty streamlined effort. We didn't spend much money in instrumenting. Even the instrument package, I think, cost $1 million for the shuttle, and we routed certain other measurements through it. But it was a small team. We spec'd out the instruments. I went out and worked with the technicians to calibrate the aero surfaces, make sure that the feedback of their position was accurate, and had calibration curves for all that. We gathered the data on the flights. Actually, aside from that, I worked with one of the engineers out at Edwards, and we came up with maneuvers that they were putting in with the stick, and I'd ride in the simulators with them and show them what worked and what didn't. And so I spent a lot of time in the simulators. In the ALT program, I actually worked in the control room, so it was a very small effort, and we were getting flight test data on the approach and landing test as well as the early orbital test. And so it was a similar. It brought back a lot of memories to see Ares 1X in motion and all the people working on it. And when I say all the people, not that many people, but really a very motivated team and really a lot of great work. As we get into having commercial entities fly our cargo and crew to space, we are faced with trying to understand what level of oversight and insight that we actually incorporate in that process, and so we can learn from what we did on Ares 1X, and we also know that what we do or what we have done with Space Shuttle over history, and what it's taken to make sure that we're flying safely. Obviously, in order to keep costs down for the commercial companies, we can't overdo it. We can't do a shuttle type program. They are going to be developing these vehicles that we put people in and cargo, and we're gonna have to make sure they're safe, but we can't do it and be over intrusive into the process, or the cost will blow up on us. But I think it's possible. We can learn from work like was done on Ares 1X. We have teams that have put together what we're calling human rating certification requirements. Those are the basic requirements, the things that you have to do in order to fly, and we have to make sure we're on top of processes. Safety is not just a pass a test. It's a process that you go through over time where you evaluate the safety aspects, the redundancy, all the critical hazards, and all those analyses that need to be done in order to make sure you're safe. And so we'll be defining what that is, and they're going to have to establish what their risks are, and have a process for evaluating risk on their programs, and we will have people involved. We haven't done that so much on the cargo because basically we don't get into their launch systems. We are most concerned about the safety of the vehicles when they get to space station, and make sure that we don't have any problems in those dynamics. But when we fly a crew, we're going to be interested from before launch to after recovery of the crew, the entire flight, abort systems, everything that goes into it, their life support, and make sure that what we end up with is a safe vehicle that we are comfortable with putting people in, and we'll do what's necessary to do that. But we're going back and redefining what that means in terms of what level oversight, what do we put into milestones where we make payments to them to make sure that we're properly doing that function. And so it's an involved process. It's a lot of learning on our part. It's working with them to try to understand what what their needs are, what they get concerned about in terms of oversight, and coming up with models of how we do that are not too intrusive yet provide the information that we need to be satisfied that we're flying safely, and it will be done. And so the judgment factor will come in as we go through all of this over time, is where you draw the line. What is enough information, and what's too much, or too much to ask for. So efforts like Ares 1X, where we streamlined our efforts, and what we're doing now in terms of MPCV and SLS, in terms of understanding and streamlining there, it all somehow needs to look very similar in the end. And that's actually, as we went through the human rating requirements development, I wanted to make sure that we isolated and kept in a central location what the key aspects of human rating requirements were. And obviously you have to tailor around it for the actual application, or what the vehicle is actually going to go do. But there should be a central set of requirements that are good for everybody, whether it's commercial or government-led development. In the end, I think those should look pretty much the same. And if we're satisfied with less insight or oversight for the commercial entities, then you have to ask yourself, why isn't that good enough for the government-developed vehicle with the potentially more established companies that we've worked with for many years building the systems that we have. So it's a big area of discussion. It's one that we have to do it carefully. We want to be responsive to trying to get these companies in a position to be successful with working with them for our flights, but also getting them to a point where they can provide services to others in a commercial sense. We have to do that in a way that is conducive to the commercial environment, but at the same time, we're satisfied with the safety that we've talked through all this, and get to the right balance in safety and streamlining. In terms of the culture at NASA, we obviously have worked through the programs. We've had the shuttle program. We have space station for human space flight. We've had Constellation that we worked well into, where we have held a kind of a standard culture that addresses how we go fly safely with human-rated vehicles. It is a challenge to the culture to streamline, and it's one, though, that I think is making progress. We have had teams off looking at what it takes to streamline that have included SNMA, that have included Chief Engineer's Office, so that everybody is a part of it and understands what's important and what's not. But it's something that will evolve over time as we implement approaches to how you streamline. You have to have a model for how you're doing it too. You can't just say, okay, we're going to cut the oversight by X%. What does that mean? How do you implement that? There has to be a model of how you go implement it. Do you put small teams at factories, which I believe is a good way to start, so they're a part of their day-to-day effort, and you don't just have people calling them all day long from NASA centers asking this and that. You have people actually there with them, going through the process with them. So that's an example of a model of how you go do that. So we have to have a model for what this means in terms of exact implementation, working relationships, and that sort of thing. The other part of it is that we can't keep asking them what if. I mean, you have to for the things that are important, but you can overdo it, and we tend to like to, as engineers, like to ask what if a lot. It's just part of our nature, I think. So you have to figure out how to have the discipline to have the right level oversight, insight, making sure that you've got an independent look here and there at a critical area, working to examine the high-risk areas more than just across the board. That's another aspect of this. We tend to want to examine every nut and bolt. Some of it is not that risky. I mean, it's pretty cut and dried as to how those things work, and we ought to be concentrating on the high-risk areas more than just across the board. So, but it is a culture shift, and it's one that's going to be gradual. But there's a lot of management discipline that's going to have to be used, and education at not just the top. They can all be bought in, but everybody all the way down the line has got to understand this is how we're going to go do this. So it's an education, and it's a management discipline to go implement. One of the key things that I took away from all this is that nobody's got a market on being able to do this work. We've got a new generation of engineers that are fully capable of going and designing, building, testing a rocket. It seemed over the years like there was a magic in the initial folks that started the space program, and certainly there was. There are a lot of my heroes and a lot of really incredible people that came together to do that. But we still have engineers that have that ability to really get in there and work hard and come up with good designs and really do a great effort on pulling this together. So that gave me a lot of confidence in our future at NASA. Another thing that I think I came away with is the power of actually flying a test of this type. I learned that here as well as on Pad Abort 1, where you see the enthusiasm, the hard work, and you see the motivation that comes from actually flying it and seeing it work well, and knowing that you've done a good job. And I saw a lot of engineers and technicians and all the people that worked on it from all levels were incredibly proud of what they'd done, and it is an incredible motivator over and above what you learn from the test. It's something that doesn't happen often enough. I would say you can always learn more. You definitely learn from everything you do in testing, but it's an incredible force for the workforce, for the people who are working on these things. An incredible amount of effort has gone into interviews like this one in terms of talking to people all across the Ares 1X effort, and it's been a very extensive effort. I actually did a previous interview that was more or less dialogue, and I think has been recorded in lessons learned. But the lessons that we learn from these have to be used. We have to make sure that the data that we get from them is really used to the fullest extent. That the experiences and the even down to the little things that went right or went wrong are important, so that we don't repeat the things that didn't work, so that we take advantage of the things that did. So this effort in pulling together all of this experience on Ares 1X is really important to us, I believe, in terms of the lessons learned, in terms of just the knowledge base that it's created, which at this point is very, very extensive. And certainly those who are working on the SLS, the Space Launch System, the Orion multi-purpose crew vehicle, and the commercial entities out there building cargo vehicles and the crew vehicles that will fly in a few years, ought to take advantage of this knowledge base, because there are gems there that they'll learn the hard way if they don't. And but in a more positive sense, there's a lot of ground that's been tread, and we ought to just take advantage of it every chance we get. So I know that it's easily accessed and needs to be. I think it'll benefit us greatly as we go down the road. Well, I appreciate this opportunity to talk about some of that experience from my perspective, and certainly in the future, I I like to tell stories about good experiences, which this was one. I would be happy to answer any questions related to Aries 1X or the other things that we've done. But certainly feel free to contact me with questions or anything that I could do to help. I'd be more than happy to do that.